Hi, this is Jack from Intel. I work for the NSG group within Intel. That's non-volatile memory solution group. Basically, it's an SSD group. And I respond for the open source, especially for Ceph, and also big data sort of thing. Today, I give you a quick high-level sharing about our work, and then looking forward about the 3D NAND, 3D XPoint is coming. It's ready and coming by middle of next year. You will see the older product. 3D XPoint going to be this year thing. Okay, NVMe. Everybody should know the NVMe. This is from ground up, and special design for flash, and also for the next generation of the SSD or non-volatile memory, because the SATA SAS, they all from a latency protocol, and way before the SSD coming on board, right? So it's a design for SSD and have super optimized cooling system. And per CPU clock is well optimized, latency good, and standard industrial standard, all protocol is standard, and then it's well accepted by industry. All the OEM have all the product. The ecosystem is there, so we think there's going to be a mainstream, and especially for OpenStack, open source community. So this is 3 configuration we're going to talk today for the Ceph. This is for per storage node. We think good, better, best, 3 configurations. The first one, they use PCIe NVMe SSD as journal. Plus, you can do caching, OSD caching. Then you have 10, 12 HDD, inexpensive, high capacity. This is 1 to 12 ratio. We think this is good, and we tested and deployed, worked with a couple of tier 1 IPDC customers. The second one, we think, second one, third one, all flash solution. And second one, we think, using one PCIe SSD as journal, fast, and then with the 4 SATA SSD, a large capacity, like 1.6 terabyte, 1 to 4 ratio, or 1 to 5, that kind of ratio. The reason behind that is like the NVMe SSD is equivalent 1 equal to 4 to 5 SATA SSD. So in this way, your journal and then flash the SATA SSD, nobody going to be your limit of performance. So that we think that's the right ratio. I have data for that. And then the last one is all NVMe. It's the best. Based on the current technology, the best performance. And I'm talking about the data of the old SSD. This is second solution. We tested with 5 node, 5 node with 5 client. We create each client we create 10 VM, totally 50 VM. We have demo downstairs as well if people wants to look at it. With this configuration, we can achieve like 1 million IOPS, more than 1 million IOPS with for 4K random read, and the latency is like 3 to 4 millisecond, and the random write performance is a little bit limited by it's limited by the Ceph context switch Ceph engine. So we can get 140K IOPS for 4K random write, still very good. And the latency is 4-5 millisecond at that IOPS. So that's pretty good. And then this is comparison with the first configuration and second configuration. Basically, we use NVMe SSD as journal. The OSD drive, one use HDD, the other one use SATA SSDs. So compared to that, you can immediately see the TCO and CapEx and OpEx is, you got a lot of saving. So you need like almost 2,000 drives, HDD, to equivalent performance as 20 SATA SSDs on the other cluster. This one is all NVMe. We create 5 node, and then each NVMe SSD create 4 OSDs. And then you can see this. You can achieving 1 million IOPS as well. It's 1.3, a little bit better than NVMe plus SATA SSD. But the point here is you have very good latency. You see at the 1 million IOPS, the read latency is around 1 millisecond, so pretty good. And we work with the ISV and using this model as a backend for the MySQL database. You guys probably already see that from Red Hat, the solutions. And looking forward, we have 3D NAND, 3D XPoint. Basically, we think the industry is going to move, at least Intel, moving to this way. One is cost reduction, like flash to replace the HDD. The other direction is trying to is 3D XPoint. It's a new medium. It's a register-free material, and it's totally new technology. It's going to be where they fit. The 3D XPoint is going to be fill the gap between the NAND flash and DRAM. They have high capacity. They can do high capacity. A little bit higher latency compared to DRAM, but it's still very good and filling the gap between the flash. You know, the flash is still like 100 to 200 microseconds. And this is a prototype. We just compare with the current fast P3700 NAND-based SSD, which we call Optane. We announced last summer as IDF. It's a it's a 3D XPoint based SSD. It's the same as PCIe NVMe SSD. Same interface, same protocol. You can just replace with current NVMe SSD just by plugging, and you get high performance. This is a 4K random read with QDAP1. And you see that the Optane drive IOPS is like almost 10 times. But if you look at the latency, the Optane drive is 9 microseconds, while the PCIe SSD is 70 to 80 microseconds. Look at the 9 microseconds. That's the if you look at the software stack from the kernel all the way to the PCIe, it's going to be take you like 4 or 5 microseconds already. So this tells your hardware latency is close to your software stack. So that's pushed the lot of work to the kernel, to the software stack in order to adopt this technology. And 3D, we think about particularly for Ceph, Blue Star. We have a couple of things in mind. Probably we want to do POC, work on those way. One is that's a PM store, persistent memory store, and we use 3D XPoint. We use Intel NVM library to have this. Okay, and then the other one is we think we can use 3D XPoint as new Blue Star as metadata, and then even as file store, we can use 3D XPoint as journal and use large 3D XPoint, because 3D XPoint SSD is going to be very large capacity per drive. We're going to deliver 4 to 8 terabyte by this year and middle of next year. So you can create a large storage by using fast 3D XPoint as well as the 3D NAND SSDs. Basically, I'm done. Summary is like NVMe is here, and OSSD solution can give you best performance, and then 3D NAND give you cost down, large OSD, and then 3D XPoint can give you close to a DRAM performance. Thank you.